Today I want to talk to you about statistical studies and sampling methods. The first three terms that you see on your terms and concepts to know, the sample survey, the experiment, and the observational study, make up the three main types of statistical studies. So let's talk, what are their definitions? A sample survey asks every member of the sample the same set of questions and records the answers. An experiment applies a treatment to some group or groups and measures the effects. And an observational study measures or observes members of the sample in a way as to not affect them by the study. If you'll go down your page just a little bit, now you can answer what are the three main types of statistical study: a sample survey, an experiment, and an observational study. Right below this, you'll see a check your understanding. Take a second, read through example 1. See if you can answer the three questions. You can use the words sample survey, experiment, or observational study to answer these questions. Pause your video if you want to, and then when you unpause it, I will have the answers here. All right, how did you do? A is a sample survey. You can see that they asked the same exact question to every single customer. B is an experiment. They're trying out a new weightlifting method, and they want to see what the results are. C is observational because they're not doing anything to the customers to change the outcome. They're simply observing. All right, let's go back up here to our definitions. The next word that we have is bias. A lot of times people get this confused with an opinion. It doesn't really have anything to do with an opinion. If a statistic or a survey is biased, it means that it is not a good representation of the entire population. If you'll turn your page over and look at example 2, we have this question. A soft drink company calls 500 people at random and asks, is our product or our rival's product the best soft drink on the market? Why is this question a potential source of bias? Hopefully you noticed that they only give you two options, our product or our rival's product. So it wasn't a good representation of the entire population. They didn't give you a chance to choose from all the soft drinks. So this could be rephrased as what is the best soft drink on the market, which would give everybody an equal opportunity to be chosen. So in an effort to avoid bias, there are many different sampling methods. One of the first I've got here on our definition list is the simple random sample. In a simple random sample, each member of the population is equally likely to be chosen. A good example of a simple random sample would be a computer-generated list where people are randomly selected from that list. For instance, you might go to the computer database for our school, and you could look at everybody's student ID numbers and then randomly choose from those numbers. Everybody has an equal opportunity, and it is a random selection. Here is a chart outlining several other sampling methods. The first is a stratified sample, and the next is a cluster sample. A lot of times people will get the two of these confused because they both start off exactly the same way. In stratified and cluster, you will begin by grouping the individuals. So I'll give you an example that you could relate to. If the population is all of the students at Page High School, I could begin by grouping them as freshmen, sophomores, juniors, and seniors. Now here's where they change. In a stratified sample, you will choose randomly some of every single group. So I'm going to choose a couple of freshmen, a couple sophomores, a couple juniors, and a couple seniors. In clustering, I'm going to randomly choose some of the groups. So maybe I only look at the sophomores and the seniors. And then I will either choose the entire group or I'll randomly choose out of those chosen groups. So stratified is a two-step process and cluster is 3. Systematic. Systematic is very easy to identify because you're going to choose according to a rule. So you'll hear them refer to something like, maybe you're standing at the doorway and you only survey every 5th person. But you'll hear that rule, and like I said, it's easy to identify. 2 of the methods that you have a high risk of bias with is convenient sampling and self-selected. Convenience is convenient for the person that is conducting the survey. For instance, if I wanted to survey all the students in Page High School, but I decided I was just going to stand in the doorway of my classroom and I would only survey the students that walked by my classroom, that is convenient for me, but it is not a good representation of the entire population. And finally, self-selected. In self-selected, you are dependent upon people volunteering to be a part of your survey. So only the people that are interested in the survey might volunteer. And once again, you might not get a good representation of the population. So take a second. I'd like you to look at example 3. You're going to choose what type of sampling method they used, and is it likely to be biased or not? All right, A was a stratified method. In this particular case, it could have bias, particularly if the age groups were not equally distributed amongst the population. Maybe there was a disproportionate amount of people in a particular age group, and then you could have bias because each age group would not be equally represented. B is a cluster, and in this particular case, it is less likely to be biased. There is a good representation of the entire population. Since we are not in class together, I am going to skip example 4. It just simply talks about designing an experiment, but I do want to focus on, if you are conducting an experiment, what is the difference between the experimental group and the control group? So if you'll flip your page back over to the definitions, let's go over that. So here are your final 2 definitions. The experimental group is the group that receives treatment in an experiment, whereas the control group will not receive the treatment. Now, it is important for me to clarify that every experiment does not have both of these groups. Sometimes you just don't have a control group. Maybe you're wanting to test different methods and just do a comparison amongst those methods. So your experimental group might be made up of, different subsets. Sometimes if you're wanting to see the effects of something on a group, it is good to use a control group. The example that we had, example 4, was talking about coffee drinkers versus non-coffee drinkers. So sometimes if you wanted to know maybe the effects of caffeine, then you're going to need a control group that doesn't have any caffeine, and you can then see what differences it makes. All right, well, that wraps up 11.2. So you can go do your online assignment now. Please Definitely use the class time to work on this and make sure that you have turned it in by 3 p.m.